Good evening. Miss Simi, are you there? Please.
Sir, I'm here, sir.
Yes. And Vandana, ma'am. Miss Vandana, are you there?
Yes, sir.
Yeah. Are we good to go?
Yes, sir.
All right. Thank you so much, Mr. Arun.
Yes,
Are
sir.
you there?
Yes, I am here, sir.
Yeah. Good evening. Please
Good
start.
evening, please. So I welcome all you to the 179th web training series of our Bharat Sahodaya powered by BTAG. So let's not wait it bit. Now it is time for me to invite our most powerful AI to introduce our moderator of this day. So here we go.
Dear educator, greetings from BTAG. You are invited to the 179th session, which deals with how labs can be experiential learning stations, and what are the lab requirements and expectations from CBSE. Now it's time to invite the moderator of this session. For that the entity, turn on our latest AI, Neo. Good evening to all. I welcome all the dignified participants to the 179th web training series of Bharat Sahodaya. Now I take this opportunity to introduce today's moderator, Ms. Simi A. Ms. Simi currently works as a science teacher in the Oxford School Trivandrum. She is a science graduate in chemistry and pursuing MA Sociology in Kerala University. She is a trained quality technician and has a wide range of experience in the Quality Assurance Department of Hindustan Lifecare Limited. She is interested in seminar presentations. She has done a paper presentation on organizational effectiveness in a national seminar conducted by Christ Nagar College of Teacher Education. Ms. Simi is a self-motivated person and she is always keen to upskill herself by learning new things. So I cordially invite you to moderate this grand session. Stage is yours.
So Simi ma'am, warm welcome. Stage is yours. And everybody, she is my friend and it's her debut performance. So God bless you.
Thank you. Thank you so much, sir. Am I audible, sir?
Yes, ma'am. You're totally audible.
Okay. So that was indeed a creative incorporation, sir, as artificial intelligence. It has the potential to transform education in many ways. So I think this is the best way I have ever been introduced. Thank you once again. So a very warm welcome to everyone. Before we begin, I would like to convey my words of gratitude to Dr. Abdul Salam sir and BTAG for giving me this great opportunity. I also extend a cordial welcome to all the participants, and it's indeed a pleasure to have each one of you in today's 179 session. So today we shall enter on an interesting journey of discussion on laboratory for experiential learning. So how labs can be experiential learning stations and how about the lab requirements and the expectations from CBSE. So in continuity with this endeavors, BTEC and the CBSE Bharat Sahodaya community, along with today's a well-known and widely recognized resource person, Ms. Vandana Agni, will seek you to provide valuable inputs in the session. So in this dynamic landscape of science education, for class 11 and 12, in the CBSE curriculum, the laboratory, it stands as a vital component. The experiential learning laboratory, it's having a vision to reimagine education by using hands-on learning and active learning pedagogy. Open-ended laboratory initiative exemplifies the intended outcomes of experiential learning cycle where the learners encounter new experiences through laboratory experiments. So reflecting the observation made interconnecting the inconsistencies between experience and understanding. So before we begin with today's session, so there are a few things I'd like to brief you about. So first one is switching on your device cameras is optional. However, any query in the midst of the session, it can be conveyed through the meeting chat box. So in order to have an interactive experience, you may note down your queries and ask them at the end of the session. Our resource person will be very happy to dispel your doubts. And next is to please click the raise hand button and wait for your name to be called out for asking your query. The participants will have the opportunity to receive the certificate only after filling up the certificate and the feedback. The link for which will be shared at the end of the session. So kindly stay connected till the end of the session. So at this juncture, on behalf of all of us present in this webinar, I'd like to thank Dr. Abdul Salam sir for empowering us with such enlightening sessions. So ladies and gentlemen, let's welcome Dr. Abdul Salam sir, who is the distinguished CBSE resource person, CBSE master trainer, and the principal of the Vibja High Bangalore. He is also the founder of BTAC, that is Bharat Transformers Academy Group, a consortium of educators and the teaching fraternity across the globe, connecting them together to empower the nation. So, sir, it's indeed our pleasure to have your gracious presence, and I would request you to take over and deliver the welcome address. Over to you, sir.
Good evening. Thank you, Miss Simi. Well, good evening, everybody, all educators, for joining us again this Saturday. Well, thank you, Vandana ma'am, for giving us this opportunity with this particular topic, which is often not, discussed, in our staff room or with the colleagues, because laboratory is taken for granted. Some experiments, do take place in laboratory. That is the end of the story. But research show that laboratory can be taken as a learning station, which many countries are, making use of. So thank you so much. We are, looking forward to the tips how we can make use of the laboratory as for experiential learning. Equally delighted to see Mr. Arun Mohan and Ms. Simi from my previous school, the Oxford School Trivandrum. The thing is that I'm very happy that you are coming forward. Many educators are coming forward to share this platform, to utilize this platform. So thank you so much to all the educators who have joined us. Let's lend our ears to Vandana ma'am. Let's all wish Vandana ma'am and Miss Simi all the very best throughout today's journey. Thank you so much for joining. Over to Simi. Thank you.
Okay, thank you, sir, for your exquisite words. So, ladies and gentlemen, amidst us, we have also the one distinguished dignitary, Ms. Annie John. Ms. Annie John, ma'am, is the treasurer of CBSE Bharat Sahodaya, and she is also the principal of MAKM School, Venaramur.
Ms. Simi, Annie hasn't joined, so you can go ahead.
Okay, sir. Okay, so ladies and gentlemen, now shall we proceed to the highlight of today's webinar? So we have a distinguished resource person, Ms. Vandana Agni. Ms. Vandana ma'am is currently working as at Power Public School, Pune, and she was MSc and MEd. She has completed in Pune University, and she has a diploma in Environment and Development, SNDT University, and course in Guidance and Counseling from Tata Institute. Madam was teaching the science and maths to students of grade 6 to 10 for the past 16 years. Vandana ma'am strongly believes that a happy class gives good results. She has attended workshops at Agastya Institute, Bangalore, and NSEA Pune, Royal Society of Chemistry, Pune, to upgrade her skills for hands-on activities in science and maths. She has trained students for Inspire Award, NCSE project, National Science Seminar. Ma'am always looks forward for learning new technique which can be implemented in the class or in the lab. So ma'am, on behalf of everyone present here, I wholeheartedly welcome you and request you to take over the proceedings of this evening. So let's take the advantage of the special opportunity we get to grow and learn together. Over to you, ma'am.
Thank you so much, Simi ma'am. Thank you for your kind words. Good morning to all the educators who are present here. I understand that all of you are really passionate and proactive and committed to this education as you all are attending this session on Saturday evening. Thank you so much. I'm just sharing this slide with you all. Sir, just see if the slides are visible. Is the slide visible?
Yes, ma'am, it is visible. Yes.
Okay. Thank you so much, Arun, sir. Okay. So today's session, we will be talking more about laboratories and how laboratory can be used as experiential learning. To start with, I would just like to show you a small video. Experiences I prefer in the laboratories. National Education Policy, NEP 2020, talks about experiential learning. And the paragraph 4.6 in chapter 4 says that we have to have integrated, enjoyable, and engaging holistic education. And for that, we need to lay emphasis on experiential learning. Also, in chapter 7, paragraph 7.5, it says about well-equipped laboratories in the school. So this is the basic requirement of the school, which is given by NEP 2020. When we are talking about experiential learning, let's see what is experiential learning. The definition given by Simon Fraser University, it says the strategic active engagement of students in opportunities to learn through doing and reflection on those activities which empowers them to apply their theoretical knowledge to practical endeavors in a multitude of settings inside and outside of the classroom. That means sometimes in the laboratories or sometimes outside the laboratories, maybe in the form of field visit, we engage children with various kind of activities, and through that they learn. Whatever experiences they gather, they reflect on the experiences and then try to develop the concrete knowledge from those. This experiential learning is not only in the laboratory, but it can be achieved through problem-based learning, case-based learning, project-based learning, inquiry-based learning, cooperative, wherein we call it as a peer learning, or apprenticeship, internships, which are provided to the students. But among all of them, laboratory or workshop or studio work, wherever it is available, is more emphasized in NEP as it gives a very hands-on experience to the students. Let's see this one activity video.
Today, we both will be teaching you the secret of flight by building a rocket. That balloon over there is also a rocket, but it does not go very far as it does not have any wings to give its flight a direction. So you see, in life, it is very important to have something
or someone.
yes, or someone who can give you direction every time you're going astray.
It helps you go very far in life.
All right. So that's how the students were gaining the knowledge through experiences. You can see the level of their confidence when they do project or activities themselves. They may be failing in that, but they will be doing it again and again. When we're talking about experiential learning, it is not possible that we will not talk about David Allen Cole. He's the one who elaborately explained the experiential learning through 4 different stages and the styles of the learners. I really like this kind of explanation when he says to start with active experimentation, wherein the person feel or do, and then having a concrete experience, that is feel and watch, then whatever he has watched, he thinks about that. So it comes as think and watch. And then after gaining these experiences and all, he performs the experiments or tries to rebuild the entire structure. And then he wants to see the result, and the cycle continues again and again. I would just like to share a small video with you all. Our presentation slides. So this is what was the cycle I was talking about. They observe action, and then they wanted to experimentize whether they'll be able to do it. So they felt they'll be able to do it. So feel and do was there. Then they tried doing it. They failed into it. So reflective
Miss
observation.
Vandana, 1 minute. Can you pull down the taskbar? It is, I think, it is coming across the, I mean, in front of the screen. Your slide. Yeah, that one. If you can pull it down. Am I right, Arun sir, or is it for me?
Yes, sir. Yes, sir. It is blocking the presentation.
Yeah, you
Is
can
it that?
hide it, ma'am. You can hide it.
Actually, you can hide it, ma'am. Yes, there is a hide option.
Sir, I can't see the hide option here.
Okay, leave it, ma'am. You can go ahead.
All right, sir. Okay, we were talking about the Kolb's cycle. So these are the 4 stages. Now, how can we see these 4 stages happening in a laboratory? Active experimentation is when students are observing a teacher doing an experiment, and then they're taking the notes of it. Then they try themselves. So that becomes a concrete experience. Now, while taking the concrete experience, they may do the experiment many times, as in, say, for example, if they are measuring the angle of reflection, then they try with different angles, and then they check whether the law remains the same. That comes the reflective observation. Once they gain this reflective observation, they can go for the law of reflection. That is their abstract conceptualization. Again, they go after doing with prism, they may go for glass lab and try the same experiment. So this way, we can see that the Kolb cycle is happening in the lab as well. What are the goals of having experiential learning through labs? The teacher can give hands-on experience to the students. Now here, I don't mean that teacher has to demonstrate the activity. No. Here, what I mean is all the students, maybe in pair or in group of 3, will be given their own set to perform, and then they perform their own experiment with the guidance of the teacher. And that is what is hands-on experience given to the students in the class, not the demonstration. When they're observing and doing the experiments, they develop their motor skills, how to handle the test tubes, the microscopes, or the physical instruments, or the chemicals in the laboratory. Also, they understand that which all experiences or experiments are possible in the lab and which are not, or they are not supposed to do, they should not do in the lab. Again, we have a very stipulated time for practicals. So within that time frame, they have to finish their task. So they need to understand the advantages and limitations of the laboratory. This is same for teachers. Teachers needs to tell them what are the advantages and limitations of the experiment. She enables students to see science or engineering in action. This is what is required for STEM. We all are doing STEM activities in the school now and utilizing engineering, technology, science, even art for that matter into it. So actually students, when they're doing activities in the laboratory, they all are doing the STEM activity by trying new concepts. All the concepts, theories, and procedures, all of them, they will be able to see how much they will be able to see in the laboratories. Teacher and students, they do conduct different kind of experiments and explore different physical media. They see the experiments which need heat, they see the experiment which need pressure, or they see how to sow the seeds in water. So all these kind of experiences they'll be able to gather in the laboratory. When the students are in the laboratory, they have different kind of questions coming in their mind. I have quoted few here saying that, sir, why do we need to use the stain? We have different kind of stains, so which provide different kind of colors to the given slide. So the child is asking, why do we use the stain? Why do these cells have a particular shape? How was the stain made and how was the lens adjusted to get a clear picture, and why they look a little different than the diagram which is given in the textbook. So all these kind of questions are coming in the mind. So when the teacher is going for a laboratory, she needs to be well prepared with all these kind of questions beforehand. I just wanted to ask you a small question. There is a Menti link here. I will post this link into the chat box. You all can answer the question which is here. In the laboratory, the learner is actively engaged in. Now, you all can state what do you think the learner is engaged in the laboratory. I'm just posting the link in the chat box. You all can. Harun sir, have you received the link?
Yes, ma'am. It is there.
Okay. Sir, I would just like to see the Mentimeter answers quickly.
Many are answering, ma'am.
Yes, ma'am, please.
Learning by doing, innovative, higher order thinking, observing, problem solving, and critical thinking, instructing meaning.
Mini ma'am, can you just show that screen? Arun sir, is it possible?
Yes, ma'am. You have to know in basics. You have to just present your screen in screen share.
Mini ma'am? Simi ma'am, are you getting that? Sorry.
Yes, ma'am. I'll read.
Yeah.
Laboratory experimentation observation. Then different way of trying.
Miss Vandana, you want
Yes,
to
sir.
share the screen of Mentimeter?
Yes, sir. But sir, I'm not able to view it here right now on my screen.
You have to go to the tab. Okay, you can, when you share screen, there is an option called share your what do you call web? And Arun sir, what is that option?
Which one, sir? In
Where-
advance?
Yeah, we can show all the tabs. Advanced share, right?
Sir, in, if it is just in the basic screen share, there is something called a screen. So whatever you see on the screen will be shown to us as also.
Madam, you got it, or you can leave it. They are typing in the chat box. Simi ma'am
Yes,
can
sir.
leave
I
it.
can see the answers in the chat box, sir.
Yeah, so you can continue.
Yes, sir. Thank you so much for the responses, teachers. Thank you all. And sorry for the inconvenience that I could not show the Mentimeter thing to you. Sir, shall I start? Okay, sir, I'm starting with my presentation again. I've just concluded whatever your answers were, that in the laboratory, the learner is actively engaged in taking initiative, being creative, constructing meaning, making decisions, being accountable for the results, being patient while doing experiments, posing questions to the teacher, investigating, experimenting, being curious about what is happening in the experiment, solving problems, and assuming the responsibility about the entire practical. Also, observation, that is what I saw, or making the notes. These were the answers given by you all. You all are absolutely right. These are the things which children generally do in the class. Now, when they're doing all these things, all the four C's, that is the 21st century skills, critical thinking, creativity, collaboration, and communication, is happening in the laboratory. Let's see how critical thinking is taking place in the laboratory. These are few experiments which I have taken. This is with respect to the angle of the mirror. Two mirrors, when they are at a specific angle, how many images can be formed? So the child is able to critically analyze by taking different measurements of the angle and arranging the mirrors. Also, he's seeing that if there is no angle but the mirrors are parallel to each other, then how the images can occur, and is able to conclude that there will be innumerable images. Similarly, in the chemical laboratory, when they are analyzing, this is experiment which is done by a few girls. They're trying to analyze with the pH meter that which all oils have acidic pH or basic pH. So critically, they are going to analyze by seeing the differences between the pH of the different oils. Let's go to the next, creativity. For this creativity, I have taken some examples from the maths laboratory. and physics laboratory. In maths laboratory, this is the activity given to standard 6 to form segments, rays, and lines. And then after forming those, these girls have shown the creativity to show how the sun rays are there in the sun in the form of segments in the center, rays after that, and lines when it is spreading throughout the world. So understanding the concept by doing the activity, and once they understand the concept, they try to do some creativity after that. There's also another video which is image which is showing that there are different kind of triangles and children are trying to make quadrilaterals out of that. And how do they arrange those triangles creatively to make the quadrilateral? You can see here conduction experiment is on, and the teacher had asked students to attach some small kind of chits, but this girl has innovatively done some smiley faces on this small rod. So these kind of experiments provide creativity to the students. Then comes collaboration. Collaboration when they do so many activities together. Maybe in the field work when they are trying to distinguish between weeds and the plants. Or when they are in the maths lab, this is an activity from the maths lab wherein they are trying to check the clock and the fractions formed by the clock, whether it is 1/4 of the clock, half of the clock, the angle made by the hands when it is 1/4, and they are going to measure it, and then they are going to check the time also. So this is how they perform the activity together, and then they conclude from the activity. There's a small activity of friction over here, which was done by the students, and for that they all had gathered different kind of materials you can see here. And on all this, with different balls and different materials, they measured how much distance the different balls travel on different materials. So you can see how the girls are doing the experiment here. So this is how, in collaboration, they learn many things together in the lab. Communication. An experiment was given to standard 8. The lesson was conversion, wherein girls were supposed to identify the zones. Now, this lesson was not taught to them. The teacher had taken them to the class and just lit the candles and asked them to distance what all they observed. And together they had to discuss and come up with the answers about the zones. And then they cross-checked it with the textbook. Also, this is an activity from the lesson electricity, wherein 8th standard students were given teamwork and they had to make some small gadgets which can run on electricity, and they had to make. So there was a competition between two groups. So naturally communication was there between them, and they had a strategy, a plan of how we are going to do it, how it will make run, and how we are going to win the given task. So all four, critical thinking, creativity, collaboration, and communication can be enhanced in the laboratories. I would like to quote here, the textbook will help them knowing, but in the lab will be able to help them constructing, analyzing, observing, and concluding. Now, when we are doing all this kind of experiment, when we have understood what are the requirements of NEP and how we can have 4 C's in the class, or experiential learning in the lab, there are certain challenges, and for that challenges, we are going to discuss some solutions. Telling the first one, safety protocols. Many of the teachers are unaware about the safety protocols in the laboratory. Also, the second one, stating limited resources. Now, limited resources is again a concern, that if they have half of the things, the experiment won't be conducted. Next is availability of trained lab personnel. This is demanding thing everywhere nowadays, that they need somebody who's well trained and will be able to arrange the practicals for all the students and help out the teacher. Mock drills and trainings needs to be observed regularly, but usually people do not care about it. It is very, very essential so that we can take care of any mishap if it is happening in the laboratory. And if more number of students are there in a school, usually the schools have 40, 50 is the strength, but sometimes in some schools they have the strength of 70 in a class or 80 in a class, then how to arrange practicals for so many students become a challenge. And then the last one is, if the situation like pandemic occurs again, how to go for virtual labs and remote learning. Let's see the things one by one. Let's see first for the safety things. We say that accident won't arrive with a bell on its neck. So for that reason, CBSE have already provided the bylaws. Rather, I would say that before seeking the affiliation, every school must satisfy these bylaws. And for that, it says there should be a science laboratory, maybe a composite one, or for senior schools, physics, chemistry, biology separate. But then it has to be equipped with all the necessary things. A link of these details I have provided in the last slide. Now, this is the structure of the laboratory given by CBSE, where it shows the model, and the model shows how the arrangement of the door should be there, or you can see the movement space is there across all the sides. So that is what is a requirement as far as safety is concerned. Then there should be a board to write, and the storage should be stacked at the end so that the students won't be disturbed by the things and they will be able to see everything well. These are the list or the general SOPs, that is standard operating procedures, applicable for all the times. This is given by CBSE again, and the link of this in detail I have provided in the last slide. See, as shown in the model, 2 wide doors are must, so that in case of emergencies, there won't be any obstruction for the students to leave the laboratories, and they'll be able to come out of the lab safely. An adequate number of fire extinguishers are must in the laboratories, or it is close to the laboratory if you keep. They need to understand whether they are supposed to use water, whether they are supposed to use soil or the fire extinguisher in case of the fire. So teachers must make a note of this. Periodical checking of vulnerable points. This is again very, very important. If there is any leakage or seepage or any oil is leaking, then we have to take care of this. Or even many times the soap container, the way it has been placed in the lab, where it is placed, so that it won't fall and there won't be any mishap. Periodical checking of electrical fittings and insulation. So if any wire is open, we need to do that also properly. So we need to insulate, and electric fittings we need to check on the regular basis. Also the gas pipe connection which is there, that also comes into periodical checking. Replacement and repairs of the gadgets and materials, this is must. Repeated instructions for the students to be given. Now, this is again important because they are children and they won't be able to understand. So even for young teachers or new teachers, we need to provide them the instructions again and again. And for that matter, I suggest that maybe this kind of safety placards can be placed in the laboratory or outside the laboratory. Safe and secure storage. When we are doing this, we have to label the chemicals or other kind of materials neatly with bold letters and put a sellotape or a plastic sheet on it so that it won't wipe off. Then safety protection provisions should be there. Fume hood. Fume hood is not there in many laboratories. That is basically used in standard 11th and 12th, where many chemical experiments we do, heating experiments we do, and it absorbs the excess of smoke. So the people with asthma or any other kind of allergy, they will be saved from that. Eye protection gadgets, gloves, all these things are must in the laboratory when we are working with the students. So all teachers and students must follow this protocol neatly. Advanced precautionary arrangement to meet any emergencies. That means the phone numbers of the ambulance or the head of the departments and all should be very, very handy in case of emergencies. Then for certain experiment, we need to take permissions of our head of the department or our principal ma'am or supervisor, so that the in case we feel that or we are in a doubt, it will be cleared. And once they give a signal, we can go ahead with those experiments. First aid box is must in the laboratory. So these were the SOPs. I have just put forward a picture wherein the safety gadgets are worn by a student. Long sleeves, or we can say a lab coat, can be worn. Many a times nowadays in the market, only long sleeves are available. So many students, they use it for 11, 12th also. They use the long sleeves instead and wear a half lab coat. That is also fine. But the hand should be protected well. Gloves should be there. Safety goggles should be there. And shoes are must in the laboratory. Different kind of hazards are possible in the laboratory. And see now, whatever is given in the slide, maybe the radioactive and all will not come in the school, but the sharp instrument hazard or animal hazard or chemical hazard is very much possible. So for a teacher, it is very, very essential to understand and know about all these hazards before doing any kind of experiment in the lab. I was talking about the safety guideline pamphlets. These kind of pamphlets are available in the market, which you can use and put them in the classes as well as in the laboratories, so that all the teachers and all the students are on the same page. They know all the rules well. In case if you don't have 3 different laboratories and you have just a composite laboratory, then these are the materials which are... Hello?
Ma'am, one comment was there.
Yes, ma'am.
Black mark that is seen towards that end of the slide. We can't see what it is written.
That is the taskbar which madam has to hide. If it is, it cannot be hidden. I think we can send the PPT to all the participants.
Okay, sir.
Yeah, you can go ahead.
Okay. Just a minute, sir. I'm sorry. Okay. So these are the chemistry instruments which are there. Say, for example, crucible, desiccator. Now, teacher must know their names properly and also their uses properly. So, which instrument can be used for what reason and how it is to be used. Say, the basic things like the acid is hygroscopic in nature. So, how to pour it, and for that, which all instruments are needed. We don't take beaker usually. We take a conical flask when we want to use the acid activity, so that the neck is very narrow and not wide like a beaker. So the teacher must know the difference between a beaker and a conical flask. And then how, with the use of this pipette, or with the use of what you can say, a small funnel and all, they can pour the things properly into the given test tube. These are some physics instruments. For friction we need, or for magnets we need. You may not have all, but at least basic as per the syllabus, we should have it. Then this is generally used in the dissection box, and a microscope is must for biology. When we order these kind of instruments, for a teacher, it is very, very essential to understand that we can't order everything from one vendor. So she needs to understand the categorization of these different materials, as in there are some glasswares, some metalwares, some plasticware or safety gadgets, and then they have to list it out separately and order it separately so that the lab will become well equipped. Okay, these are the simulations. Now, if you don't have a well-equipped lab, a teacher don't have to wait. She can always use make of her screen, and different kind of simulations providing the lab experience is available. PATE is one, or psychometer is one, and all this kind of simulations when we are using, the concept clarity is really done very well. I have put the link for this also in the last slide. This is one video wherein the teacher is explaining the practical. You can have a look at it.
Good morning everyone, students. Here today we are going to understand tracing the path of a ray of light through a prism. The same experiment we have done for refraction through glass lab. Now we will be just seeing around how
It's
the
a physics
refraction
lab.
goes through a prism. Here then you can see up onto the demonstration we have the prism. Same procedure we need to repeat it. We need to have a point of reference. So the two orbits will be using P and Q as our object. And through our object, as the incident ray is passing through the object, what will happen to this incident ray when it passes from the prism? If this prism was absent, this ray would have gone straight, so it is being indicated as E and H, a ray that goes straight in the absence of the prism. However, when we put the prism, then we will observe through the other refracting side how the angle is being, then how the image is being formed for the objects. We have R and S. These are the two pins that will indicate the image formation on the other end of the prism. So we have to observe it from PQ being the source of our object, and onto the refracting edge, R and S are the reference pins which forms up with the image. Now, as the ray is moving through the medium, it will be bending. It will show us some type of bending. We have to trace this path onto this sheet of paper which has been provided to you. So on each paper or each text, each group is being mentioned with a drawing board, white sheet.
All right. That was the... So from this video, it is clear to you all that how the arrangement of lab was. That was a physics lab. And a teacher, when she's conducting a practical, she needs to be careful about certain things so that the practical will become purposeful. I've just quoted few here. See, be clear about the intended outcomes of the experiment. So when you saw the video, it was clear that teacher explained the aim. She had written the aim on the board clearly. So children know that what they are going to do in the lab today. Know the previous knowledge of the student. So when we are conducting an experiment on a prism, she should know that, okay, they have already done an similar experiment on a glass lab and they know about certain types of rays. Be well aware about all the steps of the procedure. So you have to first read the journal properly, check yourself in the lab individually, how the practical is going on, and then maybe you can present in front of the students. Collaborate the practical activities with the other subject learning. This is what NEP is telling us, to have a collaborative, or we say integrated. So this is how we can integrate science and maths together, maybe by taking readings and then forming a bar graph. So that is the integration of science and maths. Use practical work to develop reasoning. Of course, that is what we are doing in the lab every time, that if the ray is passing like this and it is deviating, then that deviation is nothing but refraction of light. So that is what is the scientific reasoning here. Use variety of approaches to practical science. Explain the proper way of handling lab instruments and chemicals. This is again very, very important. Make students aware about threats and consequences of unsafe handling. If they don't handle the things properly, or if they don't use the chemical in a right amount, what will be the consequence? So that they need to understand very well before starting the practical. So these instructions a teacher needs to provide first. And then we need to learn something up-to-date things. See, when we were in the school, we use different kind of gadgets. Now for parallel and series connection, most of the schools are using breadboard techniques. They are very easy, handy, and very, what you can say, easy understanding for the students also. Then there is also something called as mobile LED microscope lens. So if you don't have a microscope, then you can get this kind of lenses and you can use, you can see the stomata has been clearly seen over here, or venation can be clearly seen here. Then I would also like to show you individual micro scale experiments. As I was stressing the thing regarding individual. Experiential learning is possible not by the demo, but when the students do the experiments themselves. Microscale experiment help in these things. Let me just show you a small video.
is to open the lock, and they have to do some microscale chemistry experiments to open the lock. So you can see I've got a laminated sheet with instructions. The pupils are given dropper bottles. Dropper bottles I recommend for doing this kind of thing rather than dropping pipettes, because you'd have to rinse out pipettes that could get contaminated. So everything's nicely contained in here. You can imagine having to set this up with 8 test tubes and so on. So the first reaction you're looking at here is a precipitation reaction. And you can see if I add the lead nitrate to the potassium iodide, we're getting a yellow precipitate. And this introduces chemistry to the students that we're forming a new substance, a new solid is being made. The next experiment involves fairly dilute acid, hydrochloric acid. It's at an irritant concentration, about 0.1 molar rather than a corrosive concentration. And to this, I'm adding some universal indicator, which will give a red color overall. So this introduces pH. For younger people as well, the names of the chemicals can be quite intimidating to them. So it's a literacy exercise for them, that they can follow instructions and add the correct chemicals and get the correct result, especially when they're first coming to a science classroom. The next experiment involves adding dilute copper sulfate, a transition metal, to dilute ammonia solution. And this is going to form a transition metal complex. So after this type of activity, you can tailor any recap according to the level of the students. If it was younger students, I would talk about how do we know it's a chemical reaction? What are the signs of a chemical reaction? For older students, I would talk about precipitation and ions and lattices. And you can go as far with older pupils and talk about transition metal complexes, splitting of d to d orbitals and absorption of wavelengths of light to give a color, and so on. The final one is one that's typically used for titrations. We've got some sodium hydroxide added to some phenolphthalein.
Okay, so that's how he is getting the code, and then he will write here 3, then here 7 as per the matching color, and then he will ask the students that yes, you are able to unzip or unlock the box. Now, how it has been done? This is an OHP sheet. You don't require test tubes, you don't require pipette, test tube stands, or chemicals like 2 ml, 4 ml, not at all. You just need a drop, and with that, the experiment is done. And individually, you can provide these OHP sheets. I'll just tell you how it is done.
To open the lock, and they have to do some microscale.
See, you can see a worksheet is over here, wherein it's called as a practical worksheet. And then below that, you can see a kind of copper, magnesium, zinc, iron table. And on the other side, there is copper sulfate, nitrate, magnesium. Now, on this worksheet will be given to the students. And on this worksheet, we are supposed to put the OHP sheet, that is overhead plastic projector sheet. So once we put that, we can perform our experiment on that OHP sheets using the chopper bottles, or we can say the droppers, which are available in the medical shops also. So we just have to provide that to the students and not the entire bottle of the chemicals. Many times I have seen the teachers that they are using entire bottle, and then they, in front of students, they use that entire bottle to fill the test tubes, which is absolutely wrong. So, I mean, any kind of mishap can occur there when they are using acids or alkalis. This chopper bottles are very safe, and individually we can give it to every student, and easy reaction can be observed, and the experiment is done successfully. Let's go to the next one. Can you all identify him? You can put the answer in the chat box. Yes? Simi ma'am, can you tell me if
Yes,
there
ma'am.
is any?
Yeah, Arvind Gupta.
Yes, absolutely right. He's Arvind Gupta, and when we are talking about experiential learning, how can we not talk about him? So he's the one who is, if you don't need a big laboratory or 3 laboratories, even in the laboratory, by having different kind of small things, many of the instruments which he has made, it is absolutely from trash. Rather, the website's name is Toys from Trash, wherein all different kind of scientific concepts he has used to construct, and children do it in a very active way. They enjoy doing this, and they learn various scientific concept from this. This is, I feel, actual experiential learning. So that's Arvind Gupta. Now, these are the small tips from my side if you want to conduct a practical lesson. First, of course, safety to be followed strictly, that is must. And as I said, I'm providing the SOPs and all other things in the last slide, wherein you can have all the links. Stock register and attendance register is must, and it should be duly filled. So who all were present on that day, which experiment was taken by the teacher, this is the responsibility of the teacher, that she must fill it. Test and prepare well. So you need to first go in the laboratory, test yourself so that you doesn't fail in front of the students. Precise instructions to be given. So sequence of the instructions and all the instructions neatly you need to provide to the students. Explaining objectives, that is must. You must write aim on the board. Even the observation chart always should be there on the board. Get students to work in groups, maybe in 2, 3, 4, not more than that. Be active and keep moving around the class in the laboratory. And of course, budget your time. We usually go for a block period wherein 2 periods are together for practicals so that you will be able to complete the practical well. Fine, that's my last slide. It says, above all, it's a privilege educating the scientists of tomorrow. We all are teachers and we are doing a great job in this. Practical work is a key part of scientist role. I strongly believe in it. And doing practical work is a heart of science. Make sure you come up with plenty of practical ideas and keep your students active and engaged. Let's watch this video.
Hey, look at that. वो तो चल रही है.
I feel this is actual experiential learning. Thank you so much, teachers. These are the links. You may have a screenshot of it. Or as I said that we might be sending this presentation. Thank you so much, everyone. Just before leaving, I want to say one thing. All experiments are learning experiences. So it is okay if it doesn't go as per your plan. Even the failed experience is going to teach you and the student something or the other thing. So all experiments are learning experiences, even when they don't go as planned. Thank you so much.
Well, before concluding, I would like to request the participants. Definitely, you are, masters of the subject. So you must be having, so many things to share with us. If anybody is coming forward, they can raise their hands. We can unmute you. Share your experience, your, ideas, how we can much more make the labs for experiential learning, and more than that, how it can be utilized properly. And also participants can raise their hands to, ask questions to Vandana ma'am. Please come forward. Thank you. Over to Simin.
Yes, sir. Yes, sir. So thank you so much, ma'am. Your words of wisdom have definitely added on to the intellectual pursuits of our esteemed participants, I think. Your presence enriched our webinar a lot, ma'am. So we have some queries. So let's have the question and answer session.
Miss Simi, Lukmanul's iPhone has raised his hand. You can unmute him so he can ask or he can share his thoughts.
Good evening, madam.
Yes, Miss Lukmanul, please go ahead.
Good evening, madam. Can you hear me?
Good evening, sir. Yes.
It's maybe it may not be related with the topic we discussed now. The question is how to handle a determined student in a laboratory. Maybe may not be suit for our topic today. How to handle a determined student in a laboratory, especially chemistry laboratory.
So are you talking about the children with learning disabilities in the lab?
Yes. Especially, already determined means maybe dyslexia, dysgraphia, like that. Problems may have.
Okay. Sir, I will just like to elaborate this just again by sharing the slides which we did. Just a minute. Just give me 2 minutes. So as can you see the shared slide, sir?
Yes, yes, madam.
Yeah. So these are micro scale experiments which can be given for the LD students also. But it is, it's just done with the chopper bottle, but it has to be done under the observation of a teacher. This kind of things, and even, the breadboard kind of the things or other things will help them. There are many different individual sets are available for the practical, which have got all the safety precautions also, and that also can help the LD student perform the practical alone by himself, or of course in the guidance of the teacher.
Okay, ma'am. Okay, thank you.
Miss Simi, if there are no questions, you can go ahead winding up.
Okay, sir. I think no questions are there. Okay.
Thank you so much, everyone, for the patience listening.
Okay, so ma'am, you have already enriched us with a lot of things.
Ma'am, there is one raised hand.
Okay, let's.
Good evening, ma'am. Very nice session you have conducted. Actually, you have highlighted all the points actually as a teacher, as a practical, how we have to conduct in a practical session, and what all the preparations we have to do it, and what all the safety measures we have to do it. Very wonderful session you have conducted. I have a question. I want to be the part of this CBSE Bharat Sahodaya. If I want to be a part of it, and if I want to register as a member, what is the procedure? Can you please tell it? Because I just got the link through one of my friend today. I have missed a few sessions, and I've actually entered into the middle part of your session. But still, I could make out that you have wonderfully explained all the concept as a practical teacher, what we should know, and how what all contents we have to update regarding even the tools. It's really a wonderful session. So can you please highlight on this so that it will be very nice?
Madam, I will answer that.
Yes,
you can, I have posted my number in the chat box. You can send me a message. I will send you the link. Okay.
Okay.
All right. Thank you.
Thank you, sir.
Thank you, Indu Mohan, ma'am.
Ma'am, there's one more raised hand, some Indu Mohan, sir.
Hi, ma'am. Good evening. It was a lovely session.
Thank you.
Thank you for that. Ma'am, I just have one thing. Is there any activities that you would suggest for grade 8 biology, ma'am? It's a lot of physics and chemistry that we do a lot of experiments with. So when it comes to biology, yes, we do, observe few slides and things as such. Apart from that, what can be incorporated in high school level for biology students, ma'am?
All right, very good question, ma'am. For biology, right from standard 6 onwards, we have ample of activities. Okay, there's a link of ICER which I have provided down. There also many activities are elaborated in that link. Also, right from sowing the seeds in the class, that is what I generally do with the students. In the month of June, it's a nice time to sow the seeds into glass jars or transparent plastic bottles and observe the growth throughout of the plant. So that is one thing. Secondly, with respect to the starch and proteins and all other kind of tests, those are also available, which you can do. And simulations are also available with respect to growth and the factors affecting the growth. So those all things also you can incorporate for biology, ma'am.
Ma'am, could you please post that in the chat box, the links which you are just not telling? We are not able to see because chat is disabled and we couldn't type it.
Yes,
we will send the PPT. It is there now, the last slide.
Okay. Thank you so
We'll
much.
send you the PPT.
Thank you so much.
Thank you.
That's it.
Simima, let's wind up, please.
Yes, sir. So, thank you so much, ma'am, for enriching us with your information regarding laboratory experiences and challenges, how we can develop courses. Then it's a good thing that what you told about the individual micro scale experiments. That was a new one for me also. And the tips for planning, practical lessons, everything. It was really a wonderful session. Okay, thank you so much, ma'am. So next, I would like to extend our gratitude and appreciation to Vandana ma'am for expanding our horizons with imparting knowledge on laboratory for experiential learning. And I'm sure we all participants can apply these tenets in our teaching procedures. So, dear participants, kindly note the link for certificate and feedback form has been already posted. So, you are requested to fill up the form with all the necessary details. Okay. So, I, Simi, along with the CBSE Bharat Sahodaya complex, would like to thank Madam Vandana once again for your gracious presence and enriching experience. And I would like to thank Dr. Abdul Salam sir for his gallant support and guidance. So thank you, sir, for such a great opportunity. And a big thank to the technical team, that is our Arun sir, my colleague, for a flawless execution of today's session. And most importantly, the warmest thanks to all the participants for their enthusiasm. So today is our opportunity to build the tomorrow that you want. So with that being said, it's over to you, Salam sir.
Yeah, well, thank you. Thank you so much. Madam has shared a lot of information with regard to how lab can be best used. All the more is important the guidelines provided by CBSE. Many CBSE schools are falling short of documentation, especially when affiliation comes and all. So please let us take care all documentation or what all things to be displayed in the lab and followed up, especially the safety guidelines and so on. So thank you so much for your preparation, Vandana ma'am, and thank you so much, Simi ma'am, for your help. Thank you, everyone. Arun Mohan sir, thank you for being with us throughout till the end, supporting Simi ma'am and Vandana.
Sir, even I want to thank Arun sir for his support. Thank you, Arun sir.
Yeah,
always, ma'am, always.
And
thank you,
everyone who has joined. Definitely, we will send you the PPT which Madam has shared with me, and the certificate link is there. You can save it, and you can at any time you can avail the certificate. Thank you so much once again. Over to, let's wind up. Thank you so much. Have a good night.
Thank you, sir. Good night, sir.
Thank you.